All right. Well, again, thanks everybody for joining the webinar today. We really appreciate your attendance. Hope you get a lot of value out of this. Today, we're here to talk about what's wrong with diagnostics and how can we fix it. I've got a couple of expert panelists with me today. I'll be your moderator. My name's Nick Horan. I work in business development at Twiddle Group. And first up here, we've got Mike Reynolds, owner and operator of Mass out of South Carolina. Mike, why don't you tell us what you guys are all about?
We are a sublet service that provides service to repair shops and body shops. And we generally fill all of the gaps. So calibrations, programming, we even do keys, some of the new refrigerant service, kind of anything that repair shops and body shops would need to send to a dealership or sublet. Kind of fill those gaps.
Oh, very cool. Very cool. Ralph, you want to say a few words?
Yeah, thanks, Nick. So I'm Ralph Pompey. I'm a product of Ferris State's automotive heavy equipment technology program in the early 80s. So my viewpoint today is, watching OBD1, OBD2, and my experience is really many years working in a GM dealership as a line technician, as a shop foreman, been in independent shops. So definitely have watched the challenges and how diagnostics have evolved. So interested to talk with Mike today.
Yeah, should be an interesting conversation for sure. So just to kind of set the duck a little bit, let's start with what the current state of diagnostics is. And really, if you look back for the past 20, 30 plus years, diagnostic procedures really haven't evolved all that much since print. So we really haven't, from a traditional sense, haven't taken advantage of some of the technological advances that are there. And also with traditional diagnostics, it doesn't really account for multi-problem scenarios. So when you're going through those, it's really by trouble code, by symptom, and the tech is left to their own devices based on their experience to know what the interconnectivity with all those things are. And you also add on top of that the fact that things are constantly evolving faster and faster year by year, and it's just hard to keep up. Just when you think you've got a good handle on something, on a system, it changes, right? And that causes relearning, and could also cause additional expense with new diagnostic software. And then it's compounded with a technician shortage. Now, a lot of the more seasoned technicians are kind of phasing out of the system, and there hasn't been as much interest in being a technician, unfortunately. So we've got that going on as well. So really, if we had a more efficient diagnostics, we would have happier technicians and we would have happier customers, which also means better profits for manufacturers. So the big question is, how would we go about making diagnostics more efficient? Before we dig deep into that, let's delve into how traditional diagnostics have kind of failed you guys in the past. And we'll start off with Mike. Do you have any feedback on how traditional diagnostics have failed you in the past? Any stories?
Yeah, so that's a great question. Traditional diagnostics, when we look at that, it's a terrible term, right? So traditional diagnostics would be the patterns and the processes that we would use 10 years ago to fix a early fuel injection car. And now these vehicles are pretty much driving themselves. The processes for, we look at an ignition switch used to be just a power, and that powered the vehicle on. And now these vehicles are sending communication signals to turn on modules. We have technicians that don't understand how to test the old ignition switch. And these new systems have already been out. They're already on the road, and they're coming into the shops. So we're so far behind. It's challenging to see how we ever catch up. And the downside of that is you give a technician a trouble tree diagnostic, and half the time that we go through those processes, something's going to be wrong. That trouble tree is just not going to catch, because the trouble tree wasn't written for a vehicle that's been on the road for 5 or 10 years. So technicians are intimidated by that. They know that they're not going to be successful that way. And then they're also intimidated by the diagnostics themselves. And you have up on the screen, I recently heard a story, this wasn't one of my vehicles, but it was a high-end Euro car that a shop had to, the shop couldn't get the engine started and they thought the motor was locked up. They ended up putting a motor in this car, which could have probably easily been a $10,000 job. And all that was wrong with it was a fuse that was blown. And the technicians just did. That's a standard in our industry right now. As technicians, I have a jar of fuses that I keep in all of our trucks. And when that jar gets full enough to fill a pickle jar, we're going to do some sort of raffle to point out the fact that the technicians can't diagnose fuses half the time. They don't understand electrical theory. And that's a huge issue in our industry right now.
Wow, that's definitely super interesting, and I've seen things like that in the past as well. I used to be a technician way back when. Ralph, what feedback do you have on how traditional diagnostics have failed you in the past?
Yeah, I mean, that's a great question, Nick. So my history going back to OBD1 and seeing the evolution of how diagnostics has a unique perspective because one of the jobs I had was authoring service manuals and interacting with the engineering community. And it was amazing to me to see an electrical or mechanical engineer who was kind of surprised he was asked to support authoring diagnostics for the field. And at that time, those engineers were responsible for the warranty on their component. So kind of the story I have is I was witness to an engineer writing the FEMA diagnostics, so the failure effects mode analysis, for his specific PCM, a powertrain control module back in the early 90s, where he wrote 47 pages of pinpoint tests and trouble trees to rule out every other possible cause before he would lead the technician to replace the unit. He thought that was the best way to control his warranty. In the end, technicians got paid to follow that very lengthy stream. And it may not have been the right thing for his warranty dollars. It definitely was not the right thing for the technician. So that's definitely where I saw things go awry, is people trying to protect their component and rule out everything else, and rather than doing a good diagnostic of what happens.
And that's daunting for a technician, right? I mean, a lot of technicians are getting paid flat rates, so it's how quickly can they diagnose, repair, and move on to the next job. And if you've got 30 pages of text and images and trouble trees, that's just not what a technician wants to focus their time on, which often leads to just replacing components, right?
A comment you made early on about just migrating the printed existing diagnostics to the new medium of the web. So wiring diagrams really benefited from the web because there were SVG deployment and could trace a wire and wire highlighters which were far better than the books that were in the past. Service and diagnostic information never really changed and used the power of the web and a digital delivery. In my opinion, it was just a PDF thrown on the web. That's definitely where we missed the boat several years back. There was no ability to adjust the FEMA or the diagnostic flow. Once it was out there, the PDF was static. It met a right to repair requirement, and maybe that was their goal, but it didn't help technicians.
Right. No, totally agree. I couldn't agree more with that statement. So let's go to some current diagnostic strategies here. Mike, what are your current diagnostic strategies?
That's a really, really long answer. But I love that question because that's what everybody wants to know. I mean, we have such a technician shortage, and I hate to admit the fact that experience really has a big weight in what we do. I would love to tell young technicians, hey, take this test and learn this system and learn voltage drop and electrical theory, and you're going to hit the ground running. But unfortunately, it really does come down to experience. And that's why we're having such a struggle with technicians. All of the technicians that were good back in the late 90s are getting out of the industry, right? And there's nobody to fill that gap for all this new tech. And I bring that up because our strategies are kind of unique, and it depends on what you're working on and what you're going after. The technician that can diagnose an ADAS system very effectively and efficiently is not going to be able to diagnose an EVAP system on a vehicle or an internal engine issue. Or if they are, that's a very hard to find technician. It's really all about resources, right? We use the Snap-on SureTrack system. We use Identifix. I've even Googled things before, depending on what kind of information we need to find. And road testing every vehicle, and every diagnostic you're going to walk into is going to have some different symptom, and that's kind of the challenge. And one of the stories that I like to bring up, it was a couple weeks ago, and I had a vehicle. It had some really odd symptoms, and one of the things that we did, it was one of those vehicles that had like 5 different random symptoms that you couldn't tie to one specific module or issue. And one of the things I happened to notice right out the bat was there's a mildew, like a moldy smell. And so immediately we focus our attention to, okay, this car has water in it, and we need to determine, what modules are sitting on the floor of this car and may have absorbed water. And immediately the first few things that came to mind were airbag modules that we know sit low and BCMs and things like that. And unfortunately, there's not a diagnostic class that you're going to take that's going to probably include that information of when you smell mildew, your diagnostic strategy needs to change. You need to shift the direction you're going. That's where the experience kind of comes in, and those aren't pattern failures. Maybe some windshields are known to leak in a certain place, but that's kind of where this stuff gets challenging.
Yeah, no, totally agree. I mean, I remember back when I was a technician, we had a customer that brought their Land Rover in. Well, it got towed in, actually. They left their sunroof open, and it rained pretty heavy that night. And from memory, it had to have been, every bit of, $40,000 on this brand new Land Rover just to go through and replace all these modules. That was a crazy job. So, Ralph, what are your thoughts on current diagnostic strategies here?
Well, as I mentioned previously, we're not taking advantage of the ability to adjust per field. Definitely from my legacy point of view, Diagnostics started with the complaint, the cause, and the correction. So the 3 C's still resonate for me years later, and being able to understand how a system works with the complexity that's out today is kind of at the beginning. You only get once to make a first impression, they say, in life, and that's true with customers as well. Trying to repair a vehicle, once you make that attempt to repair it, you've kind of said to the customer, yes, you've got a valid complaint. And if you don't know how it's supposed to work, that can be a real challenge.
That makes perfect sense. And when it comes to that lack of evolution, I mean, I always go right to thinking about the multi-problem scenarios, right? Because there's not a lot of times where you get a vehicle, or it doesn't have to be a vehicle. This could be anything. This could be a CNC machine for all we know, right? Oftentimes there's multiple trouble codes and or multiple symptoms. And you could go through traditional diagnostic procedures, but it's just very myopic. It's one by one. So if you don't have the experience to understand and know that these things are interconnected by some way, then you're kind of left on your own, right?
Yeah, absolutely.
Very true.
Yeah, I use the example. You look at these systems and you look at how everything's integrated. And the big thing that we do a lot of is ADAS systems. So you look at a customer driving a vehicle, if the adaptive cruise control doesn't work, that's what they're going to bring it in for. And we saw one not too long ago. The adaptive cruise control light was obviously on the dash, but it was because of a traction control system. So, we see a lot of companies out here calibrating, they're glass companies, or they're just collision sublet companies that don't know diagnostics. And they run into calibrating these systems, and they set everything up and try and calibrate and push the button, and it's not going to work. And it's not going to work not because there's an issue with that radar. They may tell the shop, hey, you need to replace that radar because it's faulty and it won't calibrate. But what the issue really is that in this specific vehicle, there's an issue in the traction control system. And furthermore, it wasn't a sensor issue. It wasn't it was actually challenging. This is a car that I worked on, and it really gave me a run for my money. It was the wrong tire size that was put on. Somebody took it to a tire shop, the tire went flat, and they actually put a wrong tire size on, which affected the ABS system because the ABS was looking at wheel speeds. It was able to determine that something didn't look right, and it was setting a wheel speed sensor code. So you put that into perspective as a technician. We're talking about a safety system, an ADAS system that we need to calibrate. If I don't have the knowledge to understand how an ABS system works and how to scope the wheel speed sensors and go through and be able to determine, hey, this one just isn't spinning the way it's supposed to, the wheel speed is wrong, we're not going to be able to diagnose that system. And generally speaking, most technicians should be able to say, okay, well, it's got a code in the radar, but it's also got a code in the ABS system. And we need to focus on the ABS system before we address the radar. But again, the technician shortage and the skill level of technicians and the available training just it isn't there.
That's a really interesting one. I'm just curious. How did you end up detecting that there was the wrong tire size?
Actually so on that particular vehicle is through a lot of driving it and getting it to set codes. On that one, we had to monitor wheel speed and just look at what the wheel speed was doing, and it was reading, right, and it was reading consistently, but it wasn't reading the correct speed, and it was enough that the system could determine, hey, this thing has an issue. But codes don't tell you. Funny enough, another anecdote: Honda has a code out that actually says wheel speed sensor installation error, and we run into this quite frequently, and I actually had one yesterday, which is fresh on my mind. And that particular code, 99% of the time, the wheel bearing is installed backwards. I know that because I've done it before. But generally speaking, we don't get that kind of information out of codes. We get wheel speed sensor fault, and it's up to us to determine what's wrong. And you can put wheel speed sensors in that vehicle all day long, and it's not going to fix it. It's just it was a wrong tire size, and it's algorithm based. And when you look at the trouble tree diagnostics, the trouble tree diagnostics isn't going to tell you if the wheel speed, if the steering angle is straight and all four wheel speeds are reading the same, the code won't set. But as soon as one wheel speed reaches 4 miles an hour difference at 30 miles an hour higher, it's going to set this code. That's too much information to include in a code. It's all algorithm based. So as a technician, when we go through the trouble tree diagnostics on that particular code, every time it's going to lead us right through replace the wheel speed sensor, replace the wheel speed sensor. Actually, what it'll take us through is replace the wheel speed sensor. If that doesn't fix it, replace the ABS module. If that doesn't fix it, replace the harness, right? Because nobody wrote diagnostics for putting the wrong tire on a car. Who thought of that,
That is definitely an interesting one for sure.
Yeah.
And that's where if they would have done a good job of theory of operation, no matter what the system is, understanding how it works, arms the technician with the information he needs to see those unexpected failures that weren't written into the traditional diagnostics.
Exactly.
And written in a way that it can be easily absorbed by the technician to where they don't feel like it's dragging them down. That's an interesting one. I'm glad you brought that one up, Mike. So let's move along to our next question here. And we could probably talk for an entire hour just on this here. So what are the biggest challenges facing today's technicians?
Well, obviously it's a lack of technicians, and it's a lack of drive for technicians to want to become successful. On the training side, we do a lot of technician training, and we focus on the aftermarket. And I look a lot at how can I be a better leader to these technicians? How can I, set a good example of this is where you want to be as a technician. But generally speaking, when you're working in a repair shop, if you are the diagnostic tech in the standard flat rate system, which still represents most of the industry, you're not going to make as much money as the guy who's doing brake jobs for 3 hours pop, and he's knocking them out in 45 minutes. And that is slowly starting to change. But, unfortunately, diagnostics shops have not found a way to make it profitable. I've got 2 GM no start vehicles for 2 independent repair shops that are on my schedule this week. Actually, I got to scramble to fit them in because they're probably going to be easy jobs. And it's sad because these shops don't have technicians that want to learn this stuff. And they don't know how to push those technicians to want to learn it because they know that they're not going to be able to pay their technicians more money because they can't bill it. They don't know how to bill it. It's not a standard in our industry to be able to sell $350 diagnostics. And that's exactly what our company does. We can easily, on a very difficult diagnostics, charge you $400 or $500 if we're diving into wiring repair or, something very difficult. And generally speaking, a lot of times, I don't see it necessarily, but a lot of times we know that the shop is eating the cost of our diag. And what happens is they've already recommended $1,000 worth of parts on this vehicle and they still haven't fixed it. And so now they have to pay us whatever they can in order for us to get it diagnosed correctly and fixed. And because they've already called the customer twice and sold them, well, the wheel speed sensor didn't fix it, and then the ABS module didn't fix it. This customer's already frustrated. They can't call them and tell them, hey, we need to pay this sublet provider X amount of dollars. And it's open-ended. We charge by the hour. So it might be $165 an hour for a Mercedes diag, and we're 4 hours into it.
And that can easily happen.
Exactly. That's a big challenge.
Yeah. I remember when I was a service manager at a shop, I would oftentimes really struggle to explain to customers why we needed the amount of time we did to diagnose something. It was a hard sell because from a customer standpoint, if you're a reputable shop, you should be able to know immediately what the problem is and to be able to tell them, hey, we're going to start with, an hour or half hour of diag time. Was a hard pill for them to swallow. And oftentimes, like you said, we ended up eating it. We ended up saying, hey, we'll start with a half hour of diagnostic time. If you decide to go with us for the repair, I'll go ahead and waive that for you.
Yep. And when you look at that model, that's the standard in the industry. But when you look at that model, what if it took you an hour and a half to diagnose a mass airflow sensor, and the mass airflow sensor cost $95 and the installation was 0.3, right? So you can't make money on that. But the other side of that I want to point out is that even if we got a system and we across the industry, because what's happening now is the diagnostics ends up costing so much money that shops either sublet it. This is what on my schedule, I've got 2 GMs, no starts. If you ask a skilled technician, what's the easiest system to diagnose, that's probably going to fall on the list, right? But even if we came up with an efficient system that was profitable for technicians to be able to make money and make a living knowing the diagnostics, we don't have a standardized system of training and we don't have enough education out there to support those technicians. And by standardized, what I mean is in the aftermarket, we have a ton of different companies and we're all teaching different things. Right now, our company's focusing on ADAS because that's what everybody wants to learn. But I can teach you ADAS systems. But if you don't understand the fundamentals of how a wheel speed sensor operates within an ABS system, you're going to take an ABS job or an ADAS job, you're going to take a calibration and you're going to fail because you're not able to diagnose that system. And generally speaking, wheel speed sensors and a lot of these systems, we look at throttle bodies and wheel speed sensors and engine controls, and a lot of them are kind of standardized across all makes and models, at least the fundamentals. But where these technicians get that education and where they learn this isn't always necessarily the same. So I can present something to a shop and I can say, look, here's the test we did, here's what you guys need to do, and here's the repair. But they might not even know how to deal with that ABS system. They might not even know the ABS system needs bled. And so that's just not standard knowledge, right? So they'll put an ABS pump in this vehicle, maybe we diagnose, and then they call me back and they say, well, it doesn't have brakes now. They didn't even realize you had to bleed the brakes. It's just not a standard. There's no standard education. There's no, there's just people working on vehicles,
Yeah. And I want to come back to the shortage of technicians out there in a minute. But before we do, this kind of poses a philosophical question in terms of, what's wrong with diagnostic trees. Ralph, based on your experience, can you comment on that?
Yeah, the complexity is really what I've witnessed from OBD1 through the 80s and 90s into 2000s. You used to have a supply base of tier ones that was the same product to all the OEMs. And now that supply base is quadrupled over time. And you have OEMs who are cherry picking. They'll buy a module from one supplier, a sensor from another, and instead of buying a cohesive package and engineered system and putting it in their car, they do the integration. And it happens that Mike would see, a vehicle at one trim level is one system from one supplier. The same vehicle on a different trim level has a different system. I've seen, 6 different charging systems in the same branded vehicle based on the trim level and the integration of it, what packages are there. So, you talk about doctors having to learn the human body and vets having to learn every animal to be able to handle it. Technicians are in that same spot. It's not just know a GM or know a Ford or an FCA vehicle. It's the different variations within those. So the complexity, agreeing with everything Mike said and adding to it challenge of the vehicle complexity, which drives all the different tools you need. You can't fix everything with a screwdriver and a wrench like you used to be able to do. Right. All those specific diagnostics, and even with right to repair, an independent shop like Mike's doesn't get the benefit of the OEM data because they don't license everything that you need in the aftermarket to the aftermarket.
Yes.
They're only required to provide information on so much. And they see it as, the market, they're trying to keep the market going to the dealership. And there's a reason why independent shops are so successful, because of the delivery, the customer focus, and the pricing differential from going to the dealer.
Mm-hmm. Oh, that makes perfect sense. It's going back to the technician shortage. We had a cultural shift, right, years ago, where the focus was really on getting a 4-year degree from a university and getting a desk job. And while all that was occurring, products kept getting more and more and more complex, and technicians' jobs became harder and harder. I was just talking to a friend of mine that I actually used to work with, and back in the day, he would have probably 90% of his time actually on a vehicle, hands-on with a vehicle. And today, 90% of that time spent behind a computer, using diagnostic software, So it's just, there's just been a huge shift. I don't think that there's a good understanding out there with folks that, being a technician, whether it's automotive or otherwise, can yield an excellent income and some really solid challenges, right, to go through on a daily basis. So,
yeah.
Mike, you've been in a long time. How, can you speak to how different it is today than it was 10 years ago to be a tech?
Actually, yeah. So that's, one of the things that I love talking about this. When I started as a technician, I worked for a shop that had a really good lead diagnostic, master technician working. And he left early on Fridays. And if he wanted the day before a holiday off, he got it. And if he wanted, if he had something he needed to do, he needed time off or, anything. And he got paid a lot of money. And we all looked up to him, right? We want to grow up to be a master tech. And in the 15 years that I've been in the industry, I see the shift to, I love using the term, the participation trophies, right? If we give our lead technician the Friday off, we need to give everybody the Friday off. And that exists in shops. And I think that kind of exists because for a long time, we had the prima donna technicians that had a chip on their shoulder. And the shop owners of that generation got fed up with it and they wanted to shut that down. And now look where we're at. We don't have technicians. That's a really big thing. And then, you look at the other side of it. I love what I do all day. And we are like, I can't put trucks fast enough on the road and get technicians in them. And we have this whole generation of young guys that grew up with computers in their hands that are shoo-ins for this kind of work. But, I can't take that guy and train him within, the experience is worth a lot. So it's hard to find those guys, but they exist. We just don't have a path to get them there. And that's kind of the challenge. When you look at, I love, I hate running the business and answering these phones and all of that. But when you get me on these 2 GM diags, it's going to be probably easy cakework, and it's going to be a little problem solving, and I'm going to have to exercise my mind. And it's a lot of fun. I enjoy it. And not only that, but I get to be the hero. I love telling this story, but for a while I had a repair shop, or actually it was a collision shop. And when I would walk on, I forget how this came about, but when I would walk into the shop, they would all start clapping. And that was just kind of the joke. But, we would get to come in there and we solve problems that they've had 5 people come and look at, and like nobody could figure it out. And we get to be the heroes all day. I mean, who doesn't want to do that? We don't get to showcase that enough. So,
Yeah, I
definitely a lot of satisfaction with a job well done, for sure.
Absolutely. And I bet you hate that, Mike, walking into a shop and having everybody clap for you,
Oh, it's awful. It's the worst.
That's awesome. So let's move on to our next subject here. Another really loaded question. And I'd like to spend a little bit of time on this one, just kind of playing catch with this. How would you describe the ideal technician experience? Mike, let's start with you.
So actually, if I can answer that, if you go back a couple slides and we could touch on that P440 code, and that'll I hopefully kind of help paint the picture. So, we get as technicians, and to be honest, I don't see as emissions faults as much anymore. But as a technician, we get a vehicle that we pull in the shop, and it's got a P0440 code. And what that code means is what that code means. I believe 440 is not necessarily a fuel tank sensor fault, but a general evap fault, which means there's an issue in the evap system. It's the first code that sets. Our issue for that vehicle may be a fuel tank sensor fault, but the diagnostic trouble tree, the official trouble tree, is going to take us through testing the vent solenoid and the fuel cap and the fuel tank pressure sensor and the purge valve. So we're going to go through all of these steps in order to get to a process. And a lot of that is going to involve smoke testing, which is a pretty time-consuming test, and a lot of other checks. You got the vehicle up in the air, you're putting it down, you're putting it up, you're putting it down, you're looking for smoke. And then some electrical testing as well. And what some of the aftermarket companies have come through, you look at Identifix and the Snap-on platform with SureTrack and all their repair link info. All of that kind of is meant to direct us quickly to what the most common faults are, right? So if the fuel tank pressure sensor is a common fault that will trip this P0440 code, we're going to see that. We're going to use our resources. We're going to look it up in Identifix or in Snap-on system, and we're going to find that as a common fault. And that's what we're going to test first, right? Why bother doing all this smoke test when we can do a quick electrical test? It's going to take 15 minutes and put us there. Those systems are awesome, and I love those systems, but they don't cover everything, right? Because not everything is a pattern failure. Not every customer leaves their sunroof open in their Land Rover. So that's where, we walk into it, and that trouble tree for that P0440 code is going to say something is wrong with the evap system. Here's what you need to do, and there's 20 pages. And as technicians, we throw that stuff away. It's useless. What I need to know, and some manufacturers are better than others about this, is what I need to know is why does that code set, and what should it be doing normally, right? Because I can't test anything if I don't know what the normal value should be. And so when we get, let's say it says test the purge valve, right? And if the purge valve has 12 volts, it's good, right? And let's say we have 11 volts, then that test is going to tell you, okay, we'll replace the PCM or replace the circuit that doesn't have voltage, because technically we didn't meet that threshold. And what we know as technicians is that thing's probably going to work with 11 volts. And granted, there may be an issue, maybe we have a weak battery or some voltage drop in the circuit, but we know as technicians that's not going to fix the issue at hand, right? So an experienced technician is going to know that, because we already know what the theory and operation is. We kind of already understand it, even though it's not written for us. Does that make sense?
That makes perfect sense. And I really like the fact that you use these different tools to lead you to a test and not just a component replacement. Because I know that a lot of folks that I know personally will use those type of things. They'll get the highest rated solution, right, based on the problem they plugged in, and they just go ahead and replace that component. Yep. Right. So I like the fact that you're using it to lead you to a test and not just a component replacement too. So you can actually get a proper diagnosis.
Well, and quite frankly, probably 60, 75% of the time that works, right? I mean, if you look at the percentages, a lot of these systems, Identifix will almost give you not in percentage, but it'll show you 500 people replace the purge valve, 500 people replace, or 1,000 people replace fuel pressure sensor, right? So, you're looking at percentages, and that's probably pretty accurate. But you're right. What that does is, for a lot of technicians, why bother doing the testing? Why not take a gamble? 500 people put a purge valve in it. Let's give it a shot, right?
They're playing the
unfortunately.
Yeah. And how dangerous is that, Ralph, to play the odds like that?
Oh, extremely. To Mike's point earlier, you call the customer, you tell them this is what it's going to be. Because you don't have the part in stock, you have to go get it, you put it on, and then you find out you're wrong. So, what's really missing today is taking the old, since I'm the old guy, the process that I had is I trained 6 different entry-level technicians when I was a master, and over time imparted my knowledge to them. And that was in the shop, order by order. Today, with the pandemic and even just with mobile repair, what support does an entry level or a newer technician have when he can't go to the stall next to him and ask his colleague or his mentor, what he should do with this problem? So the guided diagnostic solutions that are coming out really replace the mentorship and have become the force multiplier to not just like Identifix does today, give a percentage that you guess, but provide the steps that you should do in the proper order. And it's machine learning, AI, it learns from past repair. So you get the benefit of what other people have found to be the problem, but you're presented the test so you don't guess and jump to the end game. You perform the test that's relevant to your vehicle, specific to your VIN, and repair the problem that you have using the tools that we have and the data that we have from previous repair, which to me is far more beneficial than just seeing on a scan tool that with this code, 72% of the time, it's this.
Yeah. And let's take that one step further too, right? Like if there was a native integration within the scan tool that could pull all of the available values that scan tool has access to into the diagnostic to make it more intelligent, I mean, how cool would that be?
I mean, that's a great point, because one of the hassles with traditional guided diagnostics is doing all the preliminary checks. So when I used to have to get on the phone and call a call center for help just to get authorized for extended diagnostic time, they would ask you to do that. And whether you did or not, you told them you did. And I can say the most difficult problems I have had in my career are always because of a basic issue, something overlooked early or done to the vehicle, outside after it was manufactured. I had a vehicle driver education car that they installed a extra brake on the passenger side, and that caused a problem intermittently when they pinched the wire harness and the person would hit the brake. So trying to diagnose a fault like that was interjected and had no rhyme or reason definitely would have helped to have some guided check of how does this system work and where could the failure be.
Mm-hmm. Absolutely. I can totally see that. And Mike, I'm kind of thinking back to your wheel speed sensor example too. And how different would it have made the experience for you if you had a diagnostic tool that was able to be natively integrated, pull the values, but also give you the ability to explore all the possible causes, tests, and inputs for the situation you were in?
I mean, that would be great. When I look at it, though, I mean, how many possible causes? I mean, we could make a really, really, really long list. So that's where I think it's challenging. I mean, under most circumstances, that would be outstanding. But you know, even as a technician, when we have that information, are we going to be forced to use it? Are we going to go and check tires? I mean, you know, most technicians aren't going to bother to check tire size. They're going to laugh that one off. Why would it have the wrong tire size? So I think that's kind of where, if the system was able to say, okay, here's what's actually happening. You know, all 4 wheel speeds aren't matching, and here's what the wheel speed. Maybe it took a snapshot and it said, here's what the wheel speed was with the steering angle, and kind of painted it for us and said, this is how this system is supposed to operate, and this is why this code set. The code set because at 30 miles an hour, this wheel speed was reading 28. And that would be outstanding. And if somebody puts that together, I would love to use it.
Right. Yeah, totally. I absolutely agree.
Mm-hmm.
So, all right. So let's go ahead and move to a close here, guys. It's been an awesome discussion. Definitely very thought-provoking. I really appreciate you guys lending both of your expertise and coming in on the discussion. Yeah, so if you need remote diagnostics work in the Charleston area, you should definitely reach out to Mike. You can get him at masscharleston.com. And to find out more about the AI-powered diagnostics that Ralph was referring to throughout the presentation, you can visit us at tweddle.com/webinar.html, or you can email us at webinar@tweddle.com. We'd love to get a conversation going. And if I could ask, just one thing, please share this with one other person. Again, Mike, Ralph, you guys are awesome. I really appreciate your time. Thank you so much.
Thank you for having me.